This optimization problem involves finding a minimum distance. And when we find distance on the coordinate plane, we're going to need to use that distance formula. So this one is, in my opinion, one of the more challenging problems for optimization. However, if you follow along with me, I think you're going to think that it's a little bit better than it appears. So let's get started. We've got the points on the graph, y equals 4 minus x squared. We want to find the points that are closest to 0, 2. Now, this part's really important. The part that says closest to, that means we want to minimize the distance. So this means minimize the distance. Okay, minimize distance. So our primary equation is going to be our distance formula. And our distance formula is d equals the square root of x minus x quantity squared. Now this is x2 minus x1 plus y minus y quantity squared. Okay. Now those are two different x's, two different y's. And 0, 2 happens to be one of the points. Okay. So we're going to put that in for x and y. That is where, let me come back here to my yellow highlighter, our primary equation, that is where this figure over here to your left shows the primary equation. Okay, so distance equals, the square root of x minus 0 quantity squared plus y minus 2 quantity squared. We're going to want to minimize this distance, therefore we're going to need to find the derivative. This is our primary equation. This equation has one too many variables. It has an x, a y, and then of course d for distance. We need to get rid of one of those variables, and it just so happens that they gave us another equation, 4 minus x squared. That happens to be the curve in which all of the points that could be a minimum distance from 0 to, that's where they lie. And there's actually going to be two of them. There's going to be that one and that one. We just don't know where exactly they are. So our secondary equation, is y equals 4 minus x squared. And again, I'm going to highlight. Definitely highlight. There we go. So we're going to be able to rewrite this distance equation to be the square root of x squared plus, instead of y minus 2, I'm going to have 4 minus x squared minus 2 quantity squared. Now, if I'm comparing distance with distance, the square root of a number compared to the square root of a number is the same thing as comparing the radicands. So for instance, the square root of 49 versus the square root of 81. Which one is smaller? Well, 49 is smaller than 81. So you don't necessarily have to say 7 is smaller than 9. You can just say 49 is smaller than 81. And we're going to do that same thing here. I'm going to simplify the radicand, and I'm going to ignore the radical because we just want to minimize the radicand. So I'm going to have x squared plus 2 minus x squared squared. And that's equal to x squared plus, when I square the 2 minus x squared, I'm going to get 4 minus 4x squared plus x to the 4th. So this is the resulting trinomial from this binomial squared. So one more time, I'm going to simplify in descending order, x to the 4th minus 3x squared plus 4. Now we are ready to minimize, so we are going to find that derivative. So the derivative is equal to 4x cubed minus 6x. I need to set that equal to 0 and solve for x. So let's do that. Let's set that equal to 0 and solve for x. So I've got 2x that comes to the outside, leaving me x squared minus 3. And then x equals 0. Is that right? Or plus or minus 3, right? Plus or minus 3. I think I got that. Plus or minus 3. Something is a miss, I think. Set it equal to 0. 2x times x squared minus 3. I think I got this. Yeah. 2x squared minus, minus 3x. Yeah. Yeah, I think I messed up there. No, I didn't mess up there. There's my x, so I'm good. 2x times x squared minus 3. I just feel like I'm missing something. You probably know what I'm missing. 4x cubed minus 6x. I've got 4x squared, negative 4x squared, that's a negative 3x squared. I think I've got it, 2x. Oh, no, I found it. See, I just knew something was amiss. 2x squared minus 3, there. You were probably telling me, going, Miss Amos, it's right there. Okay, found it. Plus or minus the square root of 3 over 2. This one is truly not going to be my most favorite, but it's okay. It's good. So we've got our number line, okay, negative infinity, then I'm going to have negative square root of 3 over 2, 0, and then square root of 3 over 2. Hopefully you all know where I got that from, right? You add 3, divide by 2, square root both sides, plus or minus. Okay, now it's time for you to figure out what your signs are. Test into the first derivative. So we're testing into d prime. If I put negative 10 in, I put negative 10 in, I'm going to get a negative number. If I put negative 1 in, if I get negative 1, I'm going to get a positive number. If I put a positive 1 in, positive 1, I get a negative number. And if I put a positive 10 in, I get a positive number. So decreasing to increasing is your minimum. So this is the x value of a minimum. And this is an x value of a minimum. So let's go back to our picture. So we've got negative square root of 3 over 2, comma, something. And over here, that's this point right there. And this one is going to be positive square root of 3 over 2, comma, something. So how do we find that something? Oh, you're going to love this. You find that something by plugging x into your original y equals. That's how you find the corresponding y value that is on the graph, y equals 4 minus x squared. So when you put that in, you're going to get 4 minus 3 halves both times. When you put this in as well, you're going to get a 3 halves because a negative times a negative is a positive. So you're still going to have 4 minus a positive. 4 minus 3 halves is 5 halves and 5 halves. So would you might want to watch this video again? Oh, maybe. I mean, it was a pretty good one. You probably didn't find it truly enjoyable, but it might be worth a second look if you're stuck on that distance formula. So you might want to watch it again if you're stuck on that distance formula. And I think it makes it a lot better when you can understand why I took away that square root. So think about that square root of 49 comparing to the square root of 81 maybe compare the square root of 9 to the square root of 25. You don't have to actually take the square root to see which one's bigger or smaller than the other. You can just look at the radicands. Therefore, that's what we were looking at. We were just looking at the radicand.